Hey everyone, and welcome back to High Energy Podcast. I'm Esteban. We're talking about heat pumps. I know heat pumps maybe sounds like a small thing or like not the sexiest topic when you're talking about, the climate and sustainability, but these little gadgets are the unsung heroes of your home. They keep you cool in the summer, they warm you in the winter, they save you money, and they're pretty much the planet's best friend. Okay, picture this. It's a blazing hot day in Southern California. Your air conditioner's working harder than a barista during pumpkin spice season. It's very hard. And here's the twist. What if I told you that there's a device that not only cools you down in the summer, but also keeps you cozy in the winter and saves you money all year long? It's like a dream. And that is the heat pumps, okay? Your dreams have come true. The heat pumps, it's the heating and cooling system that you didn't know that you needed. So why are heat pumps such a big deal, especially here in Southern California? In Southern California, we're talking about skyrocketing temperatures. We're talking about really big energy bills. We're talking about our never-ending quest to keep California as green as our avocados. Heat pumps are like the Swiss Army knife of home climate control. They do it all while being super energy efficient and eco-friendly. To help us break it down, we've got Evan Davis with us today. He's an energy engineer. He's helping shape energy efficiency initiatives of regional utilities in SoCal and alike. And he's been on a mission to get heat pumps into homes all over Southern California. We're going to chat about what heat pumps are, why they're such a game changer for energy efficiency, and how you can start cutting down those energy bills right now. Evan, welcome to the show.
Hi, Esteban. Great to be here.
Yeah, energy engineer, first off, very cool title. And it's alliterative, which I already like.
And my name's Evan, so triple E.
Oh my goodness, Evan the energy engineer? Are you kidding? This is your destiny. This is what you were born to do.
Yeah, it feels very appropriate.
Okay, can we start with the basics? People, if they don't know what a heat pump is, I gave really high level background, but what is a heat pump? How does it work? And why is this something that people should consider installing in their homes? Just give it to us.
Yeah, absolutely. So if you think about a traditional HVAC system, it has the outside unit and then the inside fan. And what is going on is the fan on the inside is collecting heat from your house, and it goes through a refrigerant line to the outside unit where another fan is blowing that heat to the outdoors. Heat pumps are sort of miracle devices in that they work both ways. So you can take heat from the outside and move it into your house, and that would be in heating mode, or you can take heat from your house and reject it to the outside, and that would be cooling mode.
So it's not like generating new heat, it's moving heat or coolness around. And that's one of the big bonuses of it, right? It's one of the benefits.
Heat pumps are just heat movers, really, and they work both ways. And the real benefit of them is that they move this heat really efficiently. If you think about a normal furnace, if you're burning gas, you're never going to yield all the heat that's available from the gas. There's more energy in the gas than you can get by burning it. Usually furnaces are only about 80% efficient, which means that of all the energy input that you put into a furnace, you're only getting about 80% of the heat out, and that heat is used for your home. On the other hand, heat pumps in heating mode usually have what's called a coefficient of performance of 3, meaning that they can move 3 times the amount of heat as the energy required to run the device. So in comparison, they're a little bit more than 3 times more efficient than a traditional furnace.
Oh my goodness. So heat pumps are 3 times more efficient than a traditional HVAC system.
Yeah. And there are a lot of different types of heat pumps, and their efficiency varies. So I think 3 times is a relatively conservative average.
Cool. So 3 times efficiency is the start. It could be even more. I know this probably translates to saving cost. Is it something, since it's engineered better, it feels great win in terms of efficiency. Does that translate into costs? Does it help our wallets?
It depends on your utility schedule, but in general, electricity is a bit more expensive in terms of the energy content than natural gas. So there are circumstances when it will save money, but that's not 100% of the time. Um, in conjunction with solar PV, if you're a homeowner and you have solar panels on your roof, almost certainly you will be saving money because you're no longer paying for natural gas, or if you have an electric resistance system, the amount of energy that you're using is divided by about three. So in conjunction with solar PV, yes, it is a good money saver, but the benefits also come in terms of greenhouse gas emissions. Because the utilities have a lot of renewables in their grids, supplemented by natural gas for peak load, um, the greenhouse gas emissions of a heat pump are substantially less than that of a furnace.
If someone is really thinking about heat pumps, okay, we know it's efficient. We know it's good for the environment. Can you walk us through, and I know it might be like a little bit complicated, but can you walk us through some of the finances, right? Again, this big picture, high level, like what are the costs? What are the available rebates? Can you just walk us through some of that financing?
The upfront cost of heat pumps is about $2,000 to $2,500 per ton, and that's an estimate. It kind of depends on what system you have and or are installing and where the system is located. In terms of energy or cost savings, the problem is a little bit more complicated, and this is where heat pumps really benefit from on-site renewables like solar PV. But the price of natural gas currently is a lot cheaper in terms of the energy content than the price of electricity. So even if you are seeing an efficiency improvement of three times with a gas heater versus a heat pump, um, from a gas heater to a heat pump, rather, the cost of the electricity or the amount that you'd be seeing on your utility bills might go up. And that unfortunately depends on several factors, but it is currently what is more common. It depends on how you run your AC, if you have any smart devices, variable speed fans, and what utility bill schedule you are on. But with solar PV, since the sun is out and it gets hotter when the sun is out, you're getting energy from your solar PV, and that energy would go towards cooling your home in the summer. In the winter, it would be the opposite, and you still get some energy, but that's why heat pumps in conjunction with renewables are more cost effective than heat pumps alone. You might see slightly increased costs on your utility bills with just a heat pump, and that's just because natural gas is a lot cheaper than electricity, unfortunately.
It still feels like a win for the environment, right? It still feels like a win for the efficiency and the engineering of it. And, you know, energy engineer Evan approves. He's ecstatic about it. Just as many E words as we can. I know you're doing this work in Southern California. And I know sometimes it feels like, hey, is it worth installing something like a heat pump if you're in Southern California in our climate? Like I live in Culver City. Does it make sense for people who live in our community in this part of the US? And if so, what are some of the things that homeowners should know before making that switch? Like, and place us right here in Southern California.
Yeah, heat pumps absolutely work in this climate. This is kind of the prototypical climate for a heat pump because it's pretty temperate. So there isn't too much cold weather that would lower the performance of the heat pump in the winter. There's been a lot of research in recent years to create low temperature heat pumps that would function better in colder climates like Chicago or New York. And really the technology is evolving, so they're working well across the US to varying levels of efficiency, but Southern California is probably the prime climate to have a heat pump.
I'd also love to know, can you share any specific examples or any types of projects that have installed heat pumps, if they're like a multifamily or actually whatever that looks like? I would just love to know specifics of these are the types of projects and these are the types of buildings and these are the types of places where a heat pump can be really, really valuable?
Last year, like I was mentioning, we've done a lot of work with heat pump water heaters, where you take heat from the outside and put it into hot water. Um, One of the projects that comes to mind is a multifamily project in Torrance area, and it was a retirement home, and they had big old natural gas boilers that they wanted to get rid of to, increase the local air quality and decarbonize. So we installed a very large heat pump water heater system that completely took that domestic hot water off of the natural gas end use. So complete electrification of their hot water system. And we gave an incentive of about $200,000 to this property to switch from their natural gas boilers to heat pump water heaters.
That's amazing. When you say incentive, and I know getting into the nitty gritty is tough, but like, where does the incentive come from? Like, if someone is listening and they're like, I want to know more about these incentives.
I would encourage you to check at your local utilities website. Incentive structures vary by program, so the rebates that you'll see will vary between the different programs. So check your local utilities website for eligibility and efficiency requirements, and they might have a list of verified contractors that can work with you to find the right equipment and install it in your house.
Do you have any examples in Southern California that highlight the success of heat pumps, or businesses you've worked at, or buildings, or individual homeowners that have seen a change or some sort of difference from installing a heat pump?
Recently, in the past couple of years, we've seen a lot of retrofits where multifamily homeowners are interested in installing heat pump water heaters. And heat pump water heaters are a similar technology to heat pump air conditioners, but instead of providing hot or cold air to your house, they take the heat from outside and put it into a water heater. So that hot water can be used for showers or for your sinks or for laundry. And coupled with solar PV, these heat pump water heaters can be substantial money savers at certain times, and then also reduce the burden on the environment with substantially less greenhouse gas emissions.
That's great. I didn't know there were different types of heat pumps. I didn't know about like a heat pump water heater. That's so cool.
We're just getting started. There are ground source heat pumps, there are water loop heat pumps, but the most common is what's called an air-cooled heat pump, and those are the ones that you'll see in residential applications.
That's so good. I love that this is the start of heat pumps. This is like phase one of heat pumps. We're just getting started. Evan, if someone is interested in this, in do they find a good contractor to install a heat pump? Is this something that can be a DIY project? How do we do that? Someone is motivated. What are next steps? How do they turn this into a reality?
Well, you can go to your utility and you can look up rebates. Oftentimes, utilities across California will have rebates for installing heat pumps. So, starting through that process, they might have a list of recommended contractors, or you can browse products on your own. Energy Star is a great place to start. The Energy Star website has a list of all Energy Star approved products for this year, and those are the top of the line, most efficient heat pumps. Other alternatives, if you do not have a central AC system, which is the ducted system that provides cooling to all the different rooms in your house, there are what are called mini split heat pumps, and they just have a very simple refrigerant loop without any ducts. They're also called ductless heat pumps. And those systems actually can be very, very efficient. There's still the air-cooled heat pump with no advanced features, but it is really they can see higher efficiency than central systems in certain circumstances.
Man, that is so awesome. And it feels like there are so many options. There's options of regardless of the place or property that you live in. Speaking of managing properties, are there any success stories of property managers who've made the switch, right? Who've installed heat pumps or a certain type of heat pump in places that are like not just a single family residential house, right? Like a bigger property. And if someone is thinking about that, right? If someone is listening, they're like, what advice would you give to them? Or what success stories would you share with them?
We've seen a lot of retrofits for particularly the heat pump water heaters, and we haven't had any issues with any of our installations. The property ownership groups that are interested in this technology are looking to have a more sustainable portfolio in their buildings. So pretty much every time we install a heat pump, it's a success story.
I love it. You're like, Esteban, I don't want to brag, but it's kind of all success stories.
We're transitioning from a carbon intensive fuel source to a more renewable fuel source. There is still carbon in California's grid, but over time, with the state's electrification goals and renewable energy goals, that amount of carbon contributing to the grid will decrease and heat pumps will become more and more favorable. So through installing heat pumps, we're alleviating a significant burden on our atmosphere.
Okay, now I'm just curious, but what do you think gets in the way? Like, is it just awareness? Do people not know about heat pumps? Because to me, it feels like, oh, this is really incredible. This is a really great option. What do you think is slowing down adoption of installing heat pumps?
It can be expensive to transition from natural gas heating to a whole new system. Doing any sort of HVAC work is inherently pretty expensive. Now, those ductless mini splits that I was talking about, those are less substantial labor and materials to get those installed in a room. But to change out your fan coil and your outside unit, it requires a lot of work, and the materials are pretty expensive. So that's why rebates are so important, helping people to afford these new technologies that are really beneficial.
Yeah, and you were saying California, like specifically Southern California, has a bunch of rebates available, and people can like go online and do a little bit of research and find them, right?
There are definitely rebates available. SoCal REN, the Regional Energy Network, is a large provider of rebates, especially for multifamily communities. That's the program that I work on. Primarily, I work on several programs, but we provide rebates for heat pumps, especially heat pump water heaters. And yeah, I'm sure that there are other utilities in the area that will provide rebates as well.
I love it. It's good to know that there are so many resources out there. Okay, Evan, we are at the point of the show where we take questions from listeners, okay? So I've got 2 questions that our listeners have written in, and here we go, okay? The first one is from David in Encino, who asks, what is the initial cost of installing a heat pump, and what kind of long-term savings can be expected?
So the initial cost depends on the size of the system primarily. And you can expect around $2,000 to $2,500 per ton. So a ton is the amount of cold air that you need for about 400 square feet or so, 400 to 600. In SoCal, it's a little bit more like 400. So if you had a 2,000 square foot home, it would be 5 tons approximately, and again, approximately $10,000. In terms of cost savings, it really helps if you have solar PV. Otherwise, even though there is a very substantial improvement in efficiency, how much money on your utility bills, it may go up, but it may go down. And that is because electricity is currently more expensive than natural gas in terms of the energy content. So we really like to install electric devices and heat pumps when there is solar PV available.
Is there a sense of long-term savings, right? Like my thought is that electricity is becoming cheaper. That might be a long-term trend that helps with savings. Is that something to think about as all? Or do you think, hey, this is a little too abstract, specifically for David from Encino, who wrote the question?
Since California's long-term vision is to have a carbon-free grid and not include nearly as much natural gas in the electricity provided, they are actually phasing out natural gas and phasing out natural gas approved end uses in our homes. So with that phasing, there's still uncertainty about how it will affect natural gas prices. But we can potentially expect to see, as natural gas becomes smaller and smaller, makes up a smaller percentage of the market, it will become more expensive. And I think that might be a significant factor in the affordability of heat pumps.
Yeah, it feels like one of the gifts of living in California, in Southern California or in California as a whole, is that the state is committed to these decarbonization goals, right? So if you're plugged into the grid, it's only going to get cleaner and cleaner and greener. So that's great. Okay, we've got one more question, and this is a great question because it's talking about something that we haven't talked about yet. Here it is. It's from Natalie in Long Beach, who wants to know, can heat pumps handle extreme weather, or do they struggle if it's very hot or very cold? So, Evan, how do heat pumps handle extreme weather?
In the event that it gets really cold and it is outside the operating range of the heat pump, you will always be able to default to electric resistance heating. That's pretty much the standard with how these devices are constructed. But that being said, in Southern California, those situations are few and far between. In the summer, refrigerant cycles work up to high temperatures that we would expect to see in SoCal. I don't think we're going to be seeing temperatures that are so high that the refrigerant cycle would stop working.
I love it. Natalie from Long Beach, you got nothing to worry about. Okay, heat pumps can handle it. Okay, Evan, this is it. This is the end. Thank you so much for being here. And I love takeaways. Can we walk through some takeaways? Okay. Because here's the thing. The next time I go to a party, I want to go drop some knowledge on heat pumps. And then immediately people be like, yo, that guy's the coolest guy in the room. You know, that guy knows a lot about heat pumps. And that'll be my thing. Okay. So it feels like heat pumps, they are wildly efficient, right? They're this new technology that is changing the way we heat and cool our homes. Super efficient. Love it. They're a little bit of like the future of heating and cooling, right? We're all heading in that direction. There's a ton of rebates. There's like a ton of incentives and rebates available. So there's a ability to save some money, lower the cost of that. Is there anything else heat pumps related? Remember, Evan, if I'm at a party and I'm talking heat pumps, is there any other little tangible takeaway that I can share?
There is actually research about new types of heat pumps that use the thermoelectric effect and don't have any rotating parts, no compressor. They are much less efficient, and it is still very nascent in research and development stages. But there are applications for these tiny types of heat pumps, like little refrigerators that can cool beverages to 30 degrees colder than the ambient temperature. So there is new technology that is still coming out, and there are a lot of different types of heat pumps that can be installed directly into your home for HVAC and for water heating.
I love it. I love it. It's just phase one of heat pumps. We're just getting started. Thank you for these tips. Thank you for these insights and resources. And thanks for joining us, Evan. We really, really appreciate it.
Happy to be here. Thank you.
This was so great. Before we wrap things up, let's hit those key takeaways again. Okay. Despite their name, heat pumps don't just heat, they also cool. They're versatile, energy efficient solution that can work wonders right here in Southern California. They also help reduce your carbon footprint. It helps you stay comfortable year round. There's lots of incentives and rebates out there. It's like very, very exciting. Evan, thank you for joining us today and sharing all these insights and resources. And to everyone tuning in, thanks for listening. And also, we love your questions. So keep the questions coming. You can send questions to High Energy Podcast. That's high, like hello, like HI, High Energy Podcast at SoCalRen.org. And for our listeners, hey, if you're curious about making that switch to heat pumps, we have resources linked in the show notes. Cool? Also, if you enjoyed the episode, don't forget to subscribe. You can leave a review. You can tell your friends. We have so many amazing episodes and conversations coming up this season. I don't want you to miss any of it. Thanks for listening to High Energy, and we'll see you next time. Together, we can make a real difference.